Hello, today I am going to explain about Rutherford's atomic model. Lord Rutherford was a British physicist who did a famous experiment of bombarding alpha particles with a very thin gold foil of approximate thickness of 100 mm. From his experiment he got very amazing results. After the Thomson's model was as like this. He put a model of which was very similar to a pudding, and he proposed that uh, the atom is a positively charged dense sphere with electrons embedded in it like raisins in a pudding. But that model was not so acceptable. So after, and probably because of the Rutherford's experiment was not explained on the basis of this model. So Lord Rutherford's experiment was as follows. In his experiments, he took a very thin gold foil of approximate thickness of 100 mm. Gold foil. And he took radium. Radium is a good source of alpha particles, and hence because of its radioactive nature. He took radium in a lead box. Lead box is used here because lead is a residue which is left behind when a radioactive element completely loses its not completely, approximate 99% radioactivity is lost, then lead is left as a residue. So alpha particles are emitted by that particular piece of radium. Oh yes, that gold foil was also surrounded by a screen. The screen was used to observe those alpha particles. When these alpha particles hit that screen, then those alpha particles are detected by a detector. Detector can be rotated from 0 to 270 degree, and that was so when the alpha particles were allowed to hit that thin gold foil, then he observed that most of the alpha particles passed straight through that gold foil. That was an amazing observation. And very few alpha particles were deflected by small angles, let it be theta, and some alpha particles are also observed to be deflected by 90 degrees, and a very few alpha particles were rebounced back towards that radium backside. So this completely shows that there must definitely be something very dense and very small. Very dense, because as the alpha particles are helium nuclei, so helium nuclei is comparatively very big size as compared to that of electron. So it cannot be an electron to rebounce that alpha particle back, because alpha particles are obviously very much heavier than those of electrons. Then he proposed that there must be something very dense and very small, because most of the alpha particles pass straight, and very few alpha particles were rebounced back. So as very few alpha particles were rebounced back, then that dense material must be very small. So he proposed that Lord Rutherford Lord Rutherford concluded that an atom consists of a very big size as compared to that of very small nuclei. If the size of an atom is approximate 10 to the minus 10 meter, and that of an nuclei is 10 to the minus 15 meter. No, these observations were not from the Rutherford model. I'm telling you from this external side. At that time, these observations were not there. So if a piece of P represents a nucleus, then the size of atom would be of approximate 2 kilometer 2 kilometer radius. So this was an amazing observation, and it definitely neglects J.J. Thomson's atomic model. So Lord Rutherford concluded that the size of a nucleus is very, very small as compared to that of an atom, and he proposed that around dense nucleus, the electrons are revolving, and although Rutherford's model was quite successful in explaining a lot of facts, but it failed to, on the other hand side, it also failed to explain some other points like the revolution of an atom is not stationary, revolution is not stationary, is not explained to be stable, and he was also not able to, he also failed to explain the line spectrum of hydrogen atom. So this was all about Rutherford's atomic model. Thanks for watching.